Hi, welcome back. We're going to be solving Ted Shifrin's Multivariable Mathematics, problem 1.4.3, which is chapter 1, section 4, problem 3. Okay, let's let A be an n by n matrix. We're going to want to show that this set V, which is a set of all vectors in Rn, such that A times x equals 0, is a subspace. Now, this isn't going to be like a really tricky proof or anything, but it's going to be a crucial result. This is going to be a really, really important subspace. So this is definitely going to be something you want to kind of keep by your side, keep in your pocket, because you're going to find that when we start talking about spaces of linear transformations and things like that, this is going to come in really important. This is going to be a pretty important subspace. Also, to prove this, we're going to use the subspace lemma. So if you haven't seen it, go ahead and watch my video on that lemma. Okay, so let's go ahead and prove this. Let's let x and y be elements of my set V. There's a technical point here. First, we should show that V is not empty, because I mean, if it's empty, how could I be taking elements in it? But you can, if you need to, x equals to 0 satisfies this equation. So 0 is in V for sure, so it's not empty, so I can pick something in V. So we're going to skip over that point. Technically, you should be aware that that's something you have to show. You can't always just jump to saying, hey, let's pick two elements. First, you have to know it's non-empty. But yeah, like I said, x equaling 0 clearly satisfies this, so 0 is in there, so it's not empty. So let's take two elements in there. So using the subspace lemma, what I'm going to want to show is that for coefficients alpha and beta, and then of course these two vectors x and y and v, that this thing is an element of V. So if I can show that given these two, x and y and v, if I take this linear combination and it's also in V, then V is a subspace, right? Well, what lets this thing, how would I show this? When is this going to be an element of V? Well, when this thing, when multiplied by A, gets me 0. So what should I do? Well, if I want to show that this is true, I'm going to have to show that when I multiply A times this thing, I get back 0. So let's go ahead and do that. I'm going to take A, I'm going to multiply by this thing, alpha x plus beta y. Now, by properties of matrix multiplication, right, I can split this up into A times alpha x plus A, maybe I should put little parentheses, times beta y. Again, by properties of matrix multiplication, I can pull out that alpha, and I'm going to get alpha ax plus beta ay. But look, x and y we assumed were vectors in V. And what does it mean to be a vector in V? It means when I multiply A times this vector, I should get back 0. So in particular, I should be getting 0 here and here. So I get alpha times 0 plus beta times 0. But that's just 0. Oh, but wait. This thing, when I take A times it, I get 0, which means that this thing is in V. And so by the subspace lemma, V is a subspace, in this case of Rn. And that's the proof. Like I said, this is definitely going to be an important subspace. So keep this in the back of your mind. Don't let this one kind of slip into the cobwebs later on. You'll definitely want to kind of keep this in memory. All right, that's it. I'll see you in the next video.